All right, so this is the second video for 3-digit times 2-digit. So for this problem, I want us to do 216 times 54. Ignore the dog in the background. He's barking at some poor unsuspecting person walking by. All right, so I want us to estimate first. Okay, so I see that both of these numbers have to the tens place. So I'm going to round to the tens place. Okay, so if I'm looking here, this is a 5 or more, so that means that this 1 actually needs to go to a 2. So 216 is closer to 220 than it is to 210. 54, when I look next door, 4 is less than 5, so 5 would stay. So 54 is closer to 50, whoops, than it is to 60. Okay? Now I have 22 times 5. I'm going to forget about my zeros for a second. So I have 22 times 5. Well, 5 times 2 is 10. 5 times 2 is 10 plus 1 is 11. Okay? I keep pressing that button. So this 0 is a part of this 5 times 2. So I still need this 0. But I have 2 zeros that I haven't used yet. So those need to go in my product as well. So I'm saying that my estimate to 216 times 54 is 11,000. Okay. Well, looking at what I did to round, I rounded 216 to 220. That went up by 4. And I rounded 54 to 50, and that went down by 4. Okay, so this is another example of what we call an under over, meaning these are so close that we don't know for sure if it's an under or over. Now, if we were doing addition or subtraction, this, when it's up 4 and down 4, it would actually, the estimate would be our exact answer. But because we're multiplying, and when we say we round this up 4, we're rounding 54 groups 4 times. And for this one, we're rounding 216 groups 4 times. So it's a little difficult to tell over here. All right, so what I'm going to do like last time. I'm going to clear this, and I'm going to write our estimate again. There I am touching that button. Write our estimate up here, okay, so we don't forget. So we are going to do our partial products first, okay? So remember, it's 216 times 54. So we're keeping the 216 because that is our 3-digit number. I don't want to do 3 separate problems. I only want to do 2. So in order to just do 2 problems, I'm going to keep the 216. Okay? Now, I need to take 54 and I need to break that into its place value. Okay? So that would be a 50 plus 4. Okay? Not a 5 plus 4, that would be 9. This is a 50 plus 4. Okay? And so now I have 2 smaller partial problems to work. Okay, so like I showed you before, I'm going to take this 0, and instead of writing a whole row of zeros, I'm just going to write a 0 down and I'm going to cross this off. Okay, that's a much faster way. It's a good tip. So now I'm going to do 5 times 6, which is 30. Then we go to the tens. 5 times 1 is 5, plus 3 is 8. And then to the hundreds, 5 times 2 is 10. Okay? And now I come over here. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. 4 times 2 is 8. So now what I want to do is I want to add these two partial products together. I'm going to take this number and I'm just going to write it here. If I don't have enough room, I can always come over here and rewrite and do the 10,800 plus 864. It doesn't really matter how you do it, okay? This saves a little bit of room, so I don't have to do it over here, okay? So 0 plus 4 is 4, 0 plus 6 is 6, and 8 plus 8 is 16. And then that gives me 11, okay? So I have 11,664. And we always stop and evaluate whether that makes sense or not, okay? So we're looking to see, does this sound reasonable, okay? So is 11,664 close to 11,000? It is. Once we get up into the 10,000s, this is still pretty close. If I was down into like the hundreds and I was 600 away, then I'd probably say, nope, that's not close. But that's what we call relatively close. Okay, so I'm going to write this right here, and I'm going to erase this work, and now we will do this with the standard algorithm and see if we get the same answer. Okay, should we get the same answer? We should. Okay, so let me draw again, and let's do a blue. All right, so 216 times 54. All right, so we're going to forget about the 5 for a minute. It's not even there. We want to just deal with the 4. So first, 4 times 6 is 24. Then this way, 4 times 1 is 4 plus 2 is 6. 4 times 2 is 8. Okay, and remember, a good tip, before you move on to the next row, cross off your 4 because you know you're done with that, and then go cross off this that you went ahead and borrowed. Okay, so you don't borrow it again. And I'm going to go ahead and put another color here when I go to my second row, because you see it's kind of a little messy right now. So sometimes especially when you're first learning how to do this, sometimes it's good to uh, use colors. It'll really help your brain focus on what it needs to focus on. All right, so remember, this 5 is not really a 5. That 5 is a 50, right? Okay, but we just use the 5 right now because I've already dealt with the ones place here. Okay, but because this is a 50, I need to place a 0 here in this row. Okay, so 5 times 6 is 30. Carry my 3. Then I go here. 5 times 1 is 5 plus 3 is 8. And then I go here. 5 times 2 is 10. Okay. And now that I have both rows, now I just add them together. So 4 plus 0 is 4. 6 plus 0 is 6. 8 plus 8 is 16. And then I have ones. And look at that. Same answer. Okay. Now, we've talked this week about estimates and under and over estimates, and then how you can be sure that you have the right answer. Okay, so when I find a real answer and an estimate when I'm multiplying, I can't be sure that this answer is absolutely correct just by looking at my estimate. I can see if it's in the ballpark. I can say, that's a pretty reasonable answer there because that's pretty close. Okay, but what if I had messed up on my facts here somewhere? What if instead of 6 times 4 being 24 right here, what if I had accidentally said it was 25? okay? Then my answer here, this would be a 5. And so I would say that the answer is 11,665 when really there's a 4 there. So when I'm looking at the estimate, I'm still going to say, oh, well, yeah, that's pretty close. That's relatively close. You know, I'm in the right ballpark, but I don't know for sure unless I either perform the same operation with the same strategy again, or if I do another strategy. So what I would suggest you do is if you are doing standard algorithm, like this is the method, and you say to yourself, you know what, I'm not 100% sure that that is the correct answer. I see I'm in the ballpark, but I don't know for sure. You have two options at that point. Either do the standard algorithm again, okay? So if you do it off to the side and you do it again and you get the same answer, then it's probably correct, okay? Or you can do another strategy. So if you do it with the standard algorithm the first time and say, oh man, I don't know if that's correct or not, then you can do it maybe with the partial products method. And if you get the same answer, then you know it's correct, okay? All right, so now you're going to go after this video and you are going to do some practice problems with Mrs. Higby.